Hello, everybody. We're going to start chapter 3, which is on functions. We're going to talk more about functions. So, this is chapter 3. And sorry for my bad handwriting. Okay, so the first thing we want to talk about is what we call parent functions, or the book calls them the toolbox functions. Parent functions or toolbox functions. And what are they? So I'm gonna, we go to page 246 of the text. Let me just see if I can show you that page here. Okay, here we go. So you can see, zoom in a little bit. Okay, so you see the first one is called a constant function. It's just a straight line. And remember, horizontal line is always y equals to something. That's why you have f of x equals k. Recall that f of x, g of x, they all mean y. So if y equals to a number, you have a horizontal line. That's called a constant function. And then you have what we call identity function, whose graph is like this, or it could be other way around. So it's just y equals to x. If it was y equals to negative x, it would go the other way because the slope will be negative. Then we have squaring function, or I would like to call it the quadratic function, and its graph is a parabola, this smooth curve. It can open up, it can open down. And then we have a cubic function, which the graph of it looks like this, which is y equals x to the third power, or it can go the other way if you have a negative in front of that. And then if you look at the bottom here, we have the square root function, which is always like that. You see square root of x, y equals, and if there's a negative in the front, it will flip over. Then we have the cube root function like this, and again, if you have a negative in front of the whole function, it will go like that, flips over. And last but not least, we have the absolute value function, or y equals to absolute value of x. So those are your 7 basic functions that we should remember. Okay, now what happens when you move these functions? You can shift them around. So let me show you this. This is my old notes, but I thought maybe I'll show them like this to you. Let me zoom out a little bit. Okay, here we go. So you can have a vertical shift. That means if the graph goes up and down. So if you add a constant to your function, your graph will go up. If you subtract a constant from your function, your graph will go down. This is called a vertical shift, going up or down. Okay. Now, we also have horizontal shift. Now, horizontal shift is when you have a constant inside the parentheses. I will give you examples in a minute of all of these. Inside the parentheses. So if you are adding a constant inside, your graph will be shifted to the left. If you're subtracting a constant inside, your graph will be shifted to the right. This is called horizontal shift. The movement of your graph horizontally to the left and to the right. And then we have what we call, what I was just talking about. If you have a negative in front of your whole function, it will, we call it reflection across the x-axis. Basically, the graph will flip over across the x-axis. The x-axis will act as something like a mirror, so it will flip over. If you have the minus inside, then you have a reflection across the y-axis. That means it's going to go this way to the left. Now, if you have a constant other than 1 being multiplied by your function in the front, if the absolute value of that constant is greater than 1, let's say you have a 2 or a 3 or a 5, the bigger that number it is, the narrower your graph gets, or it will be vertically stretched, as another phrase. If that number, the absolute value of it, is between 0 and 1, then it will be wider or horizontally stretched. The graph will be horizontally stretched or will become wider. Okay, so let me explain a few more things before we do examples. Again, we have what we call the power functions, and it's basically the same as what we were just talking about in that table in the book. The power functions, I should say, sorry. So those are such as f of x, like the square root function, square root of x. Now, why do we call it the power function? Okay, well, what's the root? The root is 2. And what's the power on x? 1. If you remember from basic algebra review 2 weeks ago that we did, can I write it as x to the power of 1/2? Power over the root, power over the root. So that's a power function. It's a square root function. You might also get a cube root function. Can I write it as x to the power of 1/3? Again, power over the root. Remember, if the exponent is not shown, it's automatically 1. Power over the root. So that's another power function. It's a cube root function, cube root. Then you can have the quadratic function or a square function, and that's a power function because you got x to the power of 2. And obviously you have cubic function, x to the power of 3. So square function, square root function, cubic function, cube root function. And we have the absolute value functions and so forth. Okay, so let's do some examples. Let's go to page 255, which is section 3-1. And let's see. Okay, let me see. Actually, no, let me graph these. Let's do some graphing. Actually, no, sorry, I keep changing my mind. Let's go over here to these. This is page 255. Okay, so it says carefully, let me zoom in a little bit so everybody can see. It says carefully inspecting each graph given, identify the function family, vertex, inflection point or initial point, end behavior, intercepts, maximum or minimum values and where they occur, domain and the range, intervals where positive and negative, woohoo, increasing. Okay, there's a lot of stuff here. So I'm just going to do one of them. Look at number 5. This is what kind of a function? What family of function? This is a square, square function. Or we call it quadratic function because look at the degree of the function is a 2. Now, does it have a negative in the front? No, it doesn't. So if it doesn't have a negative as a leading coefficient, then your graph opens up. If this was a negative, then your graph would have been looking like this, flipped over. So that's what the negative does. Now look at this point right here. That's called the vertex. Okay? And another name for vertex, if your parabola is opening up, it's called the minimum because it's the lowest point on the graph. If your parabola was opening down, then the vertex would be called the maximum because it would be the highest point in the graph. And obviously it's a point, so you can read off the name, the coordinates. I'm not going to do that. And what else? Intercepts. Okay, you have x-intercepts, which are these 2 points, whatever they are, just pointing the basic, the different parts of it. And then you have a y-intercept, which is where the graph crosses the y-axis. And these are your x-intercepts. And let's look at the domain, because that's important. The domain of this graph is all the x values, right? So the domain, well, let's look at all the x values. Can I have any x value I want, or are there restrictions? Well, can I have this x value? Yes, because that corresponds to that point. Can I have this x value? Yes. Can I have this x value? Yes. Can I have these? Yes. Can I have 0? Yes. Can I have 1? Yes. Can I have this point? Yes. And this graph, technically, as it goes up, it keeps expanding and expanding. So I can have more x values to the right and more x values to the left. So therefore, I will write the domain of this graph right here. So the domain will be all real numbers, and that's a symbol, so you don't have to write all real numbers. You can write it out like that, or you can say, or you can write this funky looking R with that extra line over there. That's a symbol for this phrase, all real numbers. That means I can pick any domain I want. You might also see this. You might also see negative infinity to positive infinity as interval notation. So you can also write it like this, because all real numbers are possible, whatever x value you want for this graph. On the other hand, the range has a restriction. The range are the y values, right? Look at it. This point has a corresponding y value here. And then this point has a corresponding y value. This point has a value. This point, this point, this point. So I can go up. But can I go below this y value here? I can't, because there's no more graph here. So my y value starts here and then goes up. So my range, I think that's -2 if I'm saying it correctly. So my range values are y greater or equal to -2. Because it starts at -2, then it goes up, it becomes higher numbers, so it's greater or equal. And -2 itself is a value. So that's your range. You cannot go below -2. You can't go to -3 or -4 or 5 like that, because there is no graph there. There is no range. So that was the domain and the range. Okay. And there are, or let's look at number 10. See, that's a cubic function. Okay. And again, there's no minus sign in the front. That's why it's going like this. If there was a minus sign, it would go like this. Now for cubic function or cube root function like this, you don't have a vertex. You have what we call the inflection point or the turning point. For this one, is like that. So the that point would be -1, 0. That would be that point. Okay, and of course that also is the x-intercept. You have a y-intercept here, which is at 0 and 1. And then let's look at the domain and the range for this graph. Domain, range. Okay, so domain are all x values, right? Do I have any restrictions on x value? No, I can, because as the graph goes up or goes down, it keeps expanding and expanding. So I can pick any x values here, any x values there. So the domain is all real numbers. Look at the y values. Are there any restrictions? No, you can, because this graph keeps going up this way and down this way. You can pick any y value. For every point that is on this graph, you can pick a y value. So it happens that the range is also all real numbers. Let me give you a trick. Not a trick, a shortcut. For cubic function or cube root functions, like this one or this one or this one, the domain and the range are always all real numbers. There are no restrictions. Okay? All right, very good. Now, let's go, well, let's actually graph. So let's go to problem 43 on the next page. So we have this graph here, 43, we have f of x equals to square root of x plus 2 minus 1. Okay, before we do that, let's graph the generic one. F of x, or the parent function, f of x equals to square root of x. Let's try that one first. Okay, so let's dissect the sucker. What is this number in the front? It's a positive 1. So if you go back to that table in the front of section 3-1, we know the general shape of this graph is either this way or it goes this way. That's when a is positive, that's when a is negative. A is the number in the front. So it happens to be a positive 1 or a positive number, so we know the general shape will be like that. So we can make a little table and say, what if x is 0? So what's the square root of 0? 0. And f of x is your y. So that's your f of x. So that's 0. What if, now pick numbers that are perfect squares. Don't pick like 2 or 5. I mean, you can, but you get decimal numbers, then you have to estimate. Pick numbers that you can take the square root without resorting to decimals. So what if x is 1? What's the square root of 1? 1. What if x is 4? What's the square root of 4? 2. So I'm going to graph it 0, 0, 1, 1, 1, 2, 3, 4, 2. There's your graph. Okay. What's the domain? Do I have any restrictions on x values? Yes, I do, because that's the starting point of the graph. There are no x values here. There's no graph going to the left. So my domain is all x values greater or equal. What is this x value here? 0. Okay. What about the range? My range is all the y values. There is no y value down here because there is no graph. Okay, so the y values start from here, and this has a y value. If I pick a point here, it has a y value, and so forth. And this keeps going up and up, so you can have different. So the y values, the range values will be also y greater or equal to 0. So a lot of times when you're graphing, you got to define the x or the domain and the range. Okay, now let's try this one. What's your a value here? Again, it's a positive number. It happens to be positive 1. So a is a positive 1. So we know the graph will have something like that. But notice it has a h and it has a k. Remember these that we went over earlier? It has an h because it's inside the function, and it has a k. It's outside the function. So the h and the k, so let me write the general way of writing this. You can write it like this. That's the general way. Okay? So your a is the number outside. Now, your h is this value. This one didn't have an h and didn't have a k. And h and k indicates the starting value. So if didn't have any, so 0, 0, that was your starting point. But this one is not 0, 0. The h and the k are not 0, 0. So if it's a plus 2, or if it's a plus any number, you're going to shift to the left. That means the actuality, this was a negative number. So because if this h is a negative number, then a negative and a negative would give you the positive. So that's why anytime you see an h, switch its sign. Anytime you see an h, switch its sign. So my h is actually negative 2, because if I put a negative 2 here and I have a negative in the front, that gives me the positive 2. And what's my k? That's this number, negative 1. So what's the shift that's happening in comparison to the original graph? I'm shifting the graph 2 units to the left. and 1 unit down. So I have a horizontal shift of 2 units to the left and a vertical shift of 1 unit down. And that will be the starting point of my graph. So now I want to make a little table. I'm going to put that point. That's 1 point. Let's get 2 more points. Now, I'm going to pick x values that when I plug in place of x, and when I add 2 to it, I can get perfect squares. So let's say I pick 0. What's 0 plus 2? 2. What's the square root of 2? It's 1 point something. So you don't want to do that. If I put a 1, 1 plus 2 is 3, square root of 3 is decimal. What if I put a 2? What's 2 plus 2? That's a 4. Okay. So 2. What's 2 plus 2? It's 4. Square root of 4 is 2. 2 minus 1 is a 1. What if I pick negative 1? What's negative 1 plus 2? That's a 1. I can take it, so, the square root of 1. So negative 1 for x. So negative 1 plus 2 is 1. Square root of 1 is 1. 1 minus 1 is 0. So I have my 3 points, and 3 points is enough to get a sketch, a graph it. So negative 2 and negative 1, that's my starting point. 2 and 1. Negative 1 and 0. So there's my graph. And the a is positive 1, so that's why it's going this way. If this was a negative, it will go this way. Okay? All right, what's the domain? Well, you start from your starting point, and it goes this way. So therefore, your domain is x, all the x values greater or equal, what's that x value? Negative 2. Your range, y values, starting here, going up. So that will be negative 1, y is greater or equal to negative 1. And that's it. Now, again, I just want to say, if there was a negative in the front, you will have its mirror image. So you probably get something like this if you had a negative 1 in the front. And that's just a rough sketch. But it flips over. Okay, so that a value, if it's negative, it flips over. Okay, let's do 45. And in problem 45, you have a square function. So h of x, and again, that means y, equals negative x plus 3 squared minus 2. What's the general way of writing this? Y equals 2a times x minus h squared plus k. Now we know that's a square function, so we know it's a parabola. It's opening up or it's opening down. If your a is positive, opens up. If your a is negative, opens down. And this point is called the vertex. That's where your h and k is. That's where your h and k is. Remember, if it's opening up, the vertex is the lowest point, or we call it minimum. If it's opening down, the vertex is the highest point, or we call it maximum. Let's compare this to this. What's my a? My a is this number in the front. Happens to be a 1 and the negative. So my a is negative 1. So if a is a negative number, I know the graph will open down. So if you get something else, opening up or opening sideways, you know you have a boo-boo. All right, where's my vertex, my h and k? Remember what we said about h. If there is one, you always switch a sign, because you see, so h would be negative 3. That means the graph is going to shift 3 units horizontally to the left because it's negative. And then what's my k? Negative 2. The graph will shift 2 units down vertically. Okay, now sometimes you don't have a h, you might have a k, or you might have a k, you might not have an h. So it's not always that you have h and k. So you're going to locate that point. There's my point. And every parabola has this imaginary line that passes through the vertex. We call that the axis of symmetry. So I'm going to draw that line passing through there. And I'm going to make a table. I already have a point. That's the vertex. Let's pick 2 more points. Let's have 2 more points. So when you have dealing with a parabola and you have an axis of symmetry, points are mirror images of each other. So if I pick a point here, it's mirror images over here. If I pick a point here, it's mirror images right there. So let's pick an x value to the right of the axis of symmetry, or to the right of this point. So this is the x value of -3. Let's pick -2. So if I pick -2, what would be my y value? So if I put a -2 here in place of x, -2 plus 3, what do we get? Excuse me, that's on water. So -2 plus 3, that's a 1. And then don't forget your Aunt Sally, you got to square it. So 1 squared is 1. Then you multiply by -1. That gives you -1 minus 2. That gives you -3. Now, I picked -2 here. I went 1 space to the right. If I go the same distance to the left of the axis of symmetry, the y values will be the same because they're mirror images of each other. So if I go 1 unit to the right, I'm going to go 1 unit to the left. If I go 2 units to the right, I go 2 units to the left, just to keep it simple. So this is I went 1 unit to the right. I got -2. Now I'm going to go 1 unit to the left. I'm going to get -4. And I bet you the y value for that is also -3. Let's try it. If I put a -4 here, what's -4 plus 3? -4 plus 3 is -1. What's -1 squared? 1. What's 1 times -1? -1 minus 2, -3. Hallelujah. So let's plot these points. So we have -2 and -3. And we've got -4 and -3. And my graph sucks, but anyways, that's my parabola opening down. And remember, it's a smooth curve here, not a sharp point. All right, let's write the domain and the range. What's the domain? What's the range? Domain is all x values. Now for this, there are no restrictions for x values because this graph keeps expanding in both directions. So I can pick any x value to the left, to the right, and to the left. So it's all real numbers. On the other hand, the y values, I don't have any y values here because there is no graph here, so I can pick this value or this value or this value. The y values start at -2 and they go down. So therefore, my range is y less than or equal to -2, starting at that point, and then every other point has a y value less than or -2. All right, last problem before we take a little break. So let's try 51. That's an absolute value function. So 51. Problem 51. You will have f of x equals to negative absolute value of x plus 3 minus 2. Okay, let me write the general one. That will be y equals to a x minus h plus k. You see h and k coming again. So your absolute value is a sharp v opening up if a is plus, and it's opening down if a is a minus. And this point is where your h and k is, and this is that point. This is called vertex again. So it's kind of similar to that. So let's look at this one. Oh, look at it. It's just the same values as our previous example. So a happens to be -1, so we know it's opening down. Your h and k, your vertex, equal sign. You switch the sign on h always, -3, and your k is -2. So horizontal shift of 3 units to the left, vertical shift of 2 units down. So locate that point. Just by coincidence, it will be very similar to the other one. Make a table. We already have -3 and negative. Let's pick 2 more. So what if I pick -2? Right here. So I plug it in here. What's -2 plus 3? It's 1. What's absolute value of any number? It's always positive. So what's absolute value of 1? 1. But there's a negative 1 in front of it. So you multiply. That gives you negative 1 times minus negative 2. That gives you negative 3. What if I pick negative 4? Negative 4 plus 3 is negative 1, but the absolute value of it is positive 1. And when you have a negative, that makes it negative 1, negative 2, that's negative 3. This is just a coincidence that these two examples are value-wise are very similar. So here and here, that's negative 4, but this time we're going to draw a V, and there's your graph. What's the domain? All real numbers, because there's no restriction on x's. What's the range? Again, starts at negative 2, the y values, and go down. So y is less than or equal negative 2. So anyways, that was 3 examples of your different functions, and especially with the h and the k involved. So remember, always switch the sign for h. Doesn't matter what your function is. So I'm going to stop right here, and we're going to pick up in the next video.